Be talking. Usually I come with a bag full of stuff, and I've been offered something more fun for me today. I've been offered a whole world full of stuff here. Wonderful robotics and some really cool things that first we're going to do some demonstrations, and then we're going to talk a little bit about robotics and what it means to us, to everybody here, to all of us. I am particularly in love with robots. These kinds of robots were not in my mind when I was a little kid and I saw a little play called R.U.R., which was about Rossum's Universal Robots. It came from the word robota, which means surf, robots. And the robots were striking because they felt that they were being treated unfairly and the serfs were being treated unfairly. But now we're seeing that the world of robots has moved from the very stiff aluminum-covered things into absolutely devastatingly brilliant things. And so we're going to be seeing some completely new robots today, both things that have worked underwater, over water, on land, in the air, and that have changed what we think of as robots. So we're going to do some demonstrations first. Each group, there are 3 groups, and each group is going to do about a 10-minute demo, and then we're going to have a conversation. And so first I would like to introduce the brilliant Raffaello, and he is going to come up, and his colleague Segej. Now, just so you know, Professor Raffaello De Andrea is the head of Dynamic Systems and Control Systems, chair at ETH Zurich, and he's the founding member and head scientific advisor of Kiva in Boston. But basically, what he's been fascinated by is building autonomous things, which he started doing when he was 11 years old. And you'll see that there's a link between all these crazy people. They've all been doing these things since they were young enough to know better. And so we're going to see a pretty astonishing small part of their demo. What I really, can I say what Sure. I think is unfair? Okay.
Go ahead, go for it.
As impressive as the demo is, they really are screwing us, and I'll tell you why. Because this is an autonomous system. Autonomous means we don't need to fly it. It can run around all by itself. But just because of the nature of where we are in the crowd today and the fact that I was a little scared of cutting someone's head off, I wimped out, and they didn't set up the autonomous mode for this to fly over everyone's head, but we're going to see the robotic systems and learn some more about it. So Raffaello, please
Thanks, Dan.
tell us about the kind of things we were working on.
Thanks, Dan. So if we could have the slides. Great. Just to give you a little bit of introduction, background to the demonstration, there's a little bit of a story behind it. So let's get started. When you see this, keep in mind that these little robots are fully autonomous. Nobody's controlling them with a joystick, a mouse, a keyboard, or anything else. Volume, please. Volume. So that was the beginning, and things got much better over the next few years. This is autonomous, no human beings. So we competed in this competition for 6 years, international competition. It's one of the premier robotics and artificial intelligence competitions. This is another project that, again, I'm just going to show it to you, and then we'll talk a little bit about it. This is raw footage from shot by the crew of the Discovery Channel. It's about a minute long. The first 15 seconds is real time, then it's sped up, just so in the interest of time. Fully autonomous, of course. This is sped up. Has a little bit of hard time with that leg, but it learns eventually what it's doing wrong. You probably figured out what it did, move the legs out of the way so that it could grab its back. And this is what the chair does. It's a collaboration with artist Matt Donovan. It's appeared in many exhibitions and venues. You see them listed there, Luminata Festival, Idea City. It was the subject of a short film by documentary filmmaker Peter Lynch. Here you see the beginning of that film. It's a limited edition of 6. It can actually be purchased. 2 have been sold. Here you see some footage from the Yale Art Gallery. One of the things that we did, it was interesting as an exercise, is somebody pulled off the video off our website and put it on YouTube, and the cumulative number of views is over 1 million, which is nothing compared to the things that we heard about a little bit earlier today. But it's fun to read what people put. We can develop crap like this, but we still can't cure cancer. Okay? So there were hundreds of comments along these lines. Cool concept, but what the hell purpose does it serve? Find the cure for cancer, please. Other comments. These ones are at least a little bit funny. How delightfully practical. This was great. Useful for bar fights. And then, of course, the human mind is an endless reservoir of pointlessness. Wouldn't this scuff up your wood flooring? So there's these, pointed remarks. Of course, a lot of people thought that it was fake. They're just disbelievers. It's hideously fake. It's not real, start-stop animation, it's not fake. Well, this person didn't think it was fake, but thought that you could make it with $1,000. If anybody's ever worked with autonomous systems, you know that something like that would cost at least 100 times more than $1,000, if not more. And then there was a whole bunch of comments that were along these lines saying you don't see the purpose of it. The reason of doing something like this is because we can use it for something like exploring the Arctic Circle. If we're going to explore the Arctic Circle with robots, we better do it soon, unless they float. But the point here is that everybody had this idea about utilitarianism, and really the point of it was none of them, right? Does everything have to have a direct utility? Why can't we do something that's just cool? And that's what the robotic chair is. We all have different reasons why we participated in the project, but the main reason was we thought it was something just out there, really innovative, creative, that pushed the boundary. And basically, the punchline of all of this is that we think a better balance exists. Creation for its own sake inevitably leads to innovation. In the process, it's a great vehicle for education. We've trained tons of students doing this. And I really think that it leads to a more healthy relationship with technology when we can show how technology can be used for things that are fun. Just to make this concrete and not just words, let me show you a company that was started, 3 of us in 2004, and now it's over 130 people. It's called Kiva Systems. And just turn that down.
And today, robots are essential to making lots of products. But what about getting that item to you from the factory? If you've ever ordered a product online, you've probably crossed virtual paths with these. They're not security bots on patrol. They're called Kiva, and they're changing the way warehouses work. When an order comes in, the centralized server dispatches multiple robots to retrieve the products, all at the same time. Now, the people packing the order don't have to run around the warehouse, and the order ships much faster. so there's no waiting and no bottlenecks.
This is basically the production line of the future. Instead of having all the infrastructure on the factory floor, all the conveyors, all the people shoving stuff down the line, you actually have all these robots just going at it all at once.
These robots are carrying shelves full of inventory, and they're carrying them within a couple inches of each other at a reasonable high speed, and they have to do it hour after hour, day after day, without veering off course even a little bit.
An army of mobile robots carries anything from CDs to TVs, adapting in real time to changing demand, making complex inventory easy to find and orders fast and cheap to fill. It's called distributed intelligence. Each robot solves its own low-level tasks, sensing its speed and direction, thinking about negotiating obstacles, then acting, loading and delivering products. These robots never have to sleep, sort of. When their batteries run low, they come in for a recharge and some much-needed rest. And another one joins the team, keeping the warehouse humming at full capacity 24/7.
So, as I said, this company is about 130 people right now. Our biggest, oh, thanks. Isn't it amazing that we see a robotic chair fall down and then it comes back up and we clap at it? It's kind of bizarre. It's a machine, right? Yet we're clapping at it. Not finished yet, but I'll go back to the final slides. Our biggest customers are Walgreens, Staples, The Gap, Zappos. Our biggest installation with Kiva is 510 robots. So when it's been running there for about a year and a half. If we could go back to the slides, I just have a last couple of ones before I introduce Segej. Could you put the computer, the slide back on? Okay, I guess we're doing it that way. All right, so the culmination of this is now I'm a professor at ETH Zurich. I was a professor at Cornell University for 10 years and took some time off to do Kiva and all these other projects. But we developed a project class where we involve people from various disciplines, including artists. And the idea is to create things that are out there, that push the boundary of what autonomous systems can do. Some of the projects that we're doing, these are a couple of pictures. We have at the top what we call a distributed flight array. These are little items that move around, find themselves, and take flight. When they're in the air, they break apart, fall down to the ground, and the whole process repeats itself. We have a balancing cube. You put it on any of its corners, and it balances itself. We have something called a blind juggler. I'll leave it to you to go to our website to learn a little bit more about it. These are the people that are in our group. And one of these individuals is Segej, who's going to give a demonstration of some of the things that he's working on. Segej actually went through this program. He was an undergraduate at Cornell University where he was involved with the RoboCup team. He actually went on to be involved in the DARPA Grand Challenge of the Cornell team that did quite well in the competition. And with that, I'll pass it over to Segej.
Down to business. So this is a bit of an interactive demonstration, since this conference is, after all, about, people and not just robots. So yeah, this is one of the flying machines that we use in our space. It's called a quadrotor. I hope everyone got a nice and close look at it. Yeah, if it gets hot, you just call this thing over and hover it over your head. Here's another view of the Beastie. Yeah, it's just like a helicopter, but it has 4 propellers instead of 1 or 2, like normal helicopters do. And here it's actually hovering in our space. So it's just a part of an autonomous system. Each of these things aren't autonomous, but in our space, in our lab, the entire space is autonomous. So we can actually show you a quick picture. It's a 10 by 10 by 10 meter space, so you can imagine 1,000 cubic meters of air. There are nuts on all sides, and what happens inside is that we have these vehicles. They're tracked by cameras overhead, and they fly themselves. Or rather, there's a centralized computer that runs all of them. And you can imagine that you have one vehicle, you can have 10, so on. So we actually have a few videos. The space is quite new, so these are really just previews of what's possible. Here you're seeing 2 vehicles. So this is completely autonomous, no human input at all. In fact, you have to keep in mind that if you had human pilots trying to do this, it'd be challenging, if not impossible. These vehicles are passing within about 10 centimeters of each other without crashing. So you can imagine that it's pretty high tech. So recently we went to try some of the more 3D maneuvers. Here's a flip. This is quite challenging. It takes all of the ability of the vehicle to actually complete the flip and stop before crashing. And of course, developing this is a lot of fun because you try it and sometimes you get pretty spectacular crashes. So this is another one of our more recent innovations, if you want to call that. We're always looking for challenging problems challenging and fun problems to use the system with. So this is one of them. So we attached a badminton paddle, and we want to play it. We want the robots to play badminton with each other or even with people. So you can imagine what that would look like. Maybe come back in a few years, maybe you'll see it. Yeah. So this is a preview of the actual space. Go to our website. We're on the interwebs. We have a blog. So come and see us. Thank you.
Now, thank you. That was wonderful. Amir Shapiro, we're going to have a different kind of robot, a whole different species, in a way, of robots. And we have a real treat as well. 2D and 3D snakes are going to come alive, and you're going to see some wonderful things. Just so you know who Amir is, he's a lecturer at the Department of Mechanical Engineering at Ben Gurion University in the Negev. He's been interested in walking robots, snake robots. He was taking things apart as kids, but he became seriously interested in putting things together when he got into graduate school. So he's been focused. His fascination is how to make robots move on rough terrain and in unstructured environments. And I think you'll see how challenging and how fascinating that can be.
Okay. We'll start with the first demonstration of a snake-like robot. Here, it moves forward by having a traveling wave that goes along the snake. And you see that the snake has it's not very stable here for some reason. And it can go backward. Can you see there? So the links here are football shaped, and it uses completely rolling contact with the ground, and therefore it can move very efficiently. And as you can see here, this snake can move only forward and backward, and that's the reason we thought of developing such a snake, but a three-dimensional one that can move also to the sides. And I need just a few seconds to connect the other snake. Just a second. So this snake, I have a movie in between. Just a second, I'll show it here. What?
Well, I'll tell you what happened. Customs, it ended up, where did it end up? It was
in Vienna.
Yeah. So last night I get a conversation, oh, by the way, my snakes are in Vienna. And so I was like freaking out.
Can you show it? Can you show? Okay. So the reason we developed the two-dimensional snake robot was originally for climbing between two parallel walls, as you will see in the video. And using rolling contact allows us to climb between walls that are far apart than other possible by snake robots. Can you see it? Yeah. Okay, so show the video. So it's exactly the same snake robot with exactly the same motion, but now we just push to the sides between these two walls, and just by pushing, it allows to have enough friction to hold itself above the ground. And you can see that it goes up to the ceiling there. Hopefully this would work as well. So, as you saw before, when the snake was falling to the side, it wasn't very stable. So now we have different kind of motion in order to have the snake stable. I'll begin. Can you see it? Maybe you can project from the camera here.
Can we put it on the table?
We can, yeah. You want to put it on the table?
Or our Steadicam fellow who's not getting steadier after the day. He's exhausted. What?
So I'll do it again. You see, it needs to have this S shape in order, it's not exactly S, this wave shape, in order to be stable, and there is a vertical wave that goes forward, and this is what allows the snake to advance. And now, I'll have it, well, this is to the side actually. So this is crawling to the side and turning left in this case, as you can see. So the snake is like an arc, and the traveling wave travels along the snake, and this is how it moves to the right side, can be also to the left side. And I just need the last thing, maybe here. No, it's too small. Okay, the last thing is a crawling motion forward, like a screw motion. As you can see it here, it uses traveling waves in both directions, the horizontal and the vertical direction, and this combination gives this screw-like motion. And I can do it backward. Oh. Yeah. Okay. So that's about snake robots. And I want to show you a video of my other robot for climbing robots. And I want to show you also the module that the snake are made of. You see exactly the same as the two-dimensional snake that the links are in a football shape. In the three-dimensional, it is also have the football shape, but in both directions. And the entire snake is composed with only a single link. This is the only mechanical part that there is there, and few servo motors, 18 to be exact. And you can see, you saw the video, that it has the football shape in both directions, the horizontal and vertical direction. And now we move to climbing robots. Okay. So climbing on wall is very attractive, very challenging. And first, when you think about climbing, you think how to attach to the wall. And this robot attached to the wall using magnets. And it has magnets on compliant wheels and can go over any kind of wall. And it uses for searching on ships, boats, and other structures, other metal structures. This is a different kind of robot that uses different method to attach to the wall. Instead of using the magnets, now it uses just a hot melt glue. That's exactly the same that we have at home. You can see, where is it? You can see here the sticks, the glue sticks, and it leaves a trail behind of the glue, and therefore we call it a snail-inspired robot.
My mother would complain about the mess you're leaving behind.
Yes. This is a door in my lab. And the students are taking it off all the time. And it uses here a gas blower in order to heat the glue. And then we thought, well, using hot melt glue, it's a little difficult to maneuver on the door. So we just have designed a new robot that has sticky wheels. This is just a sticky tape on the wheels of the robot, and you see how it can move over the whiteboard, can go over a corner, as you can see here, and do all kinds.
And there's a lot of confidence.
Yeah, that's the reason I didn't bring them, because it doesn't always work. So, and this is the last one. This robot climbs like a cat. It has these claws on the foot pad, and it climbs on the wall by attaching to the roughness of the surface, as you can see here. And it just needs to feel the surface. It feels how much torque it can apply, and then it moves its weight to the correct direction in order to advance. Okay.
Beautiful job.
Thank you very much.
Okay, and we'll be speaking to Amir and Raffaello and in just a moment. But first, our friends Roy Roth and Yael Tevet, Yael, are going to impress us again. They gave us the drum introduction, and we'll hear a full range of their creative output in a second, because they have an incredible experience design studio, and they've been doing stuff all around, especially in Jerusalem. Does this work? What? The mic?
I don't have the neck mic. Mine is, does this work?
Where's the hand mic?
It works. So
Yeah, it
hi,
works.
I'm Roy Roth.
Where's the? I think it's the wrong laptop here. It's your laptop.
Oh.
Yeah. Where did you put it then? On this laptop.
Yeah, thanks.
Oh, on the other laptop. Let me get rid of
Okay.
One moment, please. While we're waiting, let us roll the robot housekeeper video if you've got it. Can you roll the video that I had as we fix this little thing here? Here's a video I found that I thought was really helpful from the Japanese. How I see robots in my daily life. This would put me out of a job completely at home. Yep. Honey, I'm home. All right. Thank you.
So,
Okay,
hi.
so now we can.
So I'm Roy Roth.
Amir Tevet.
And actually, we're a design studio. We're not a technology studio, but we stumbled upon robots, and we've used them to create a very unique orchestra or an experience in Jerusalem in 2006. So I want to show you two projects. The first one, who's a part of it we can see here, it's called Soundscapes, and it's a very vast robotic orchestra playing in an ancient citadel in the Tower of David in Jerusalem. Tower of David is situated between the east and west of Jerusalem, just between all the cultures, all the religions. It's a very emotionally and energetically charged place. So you can see it here, and you can see some of our sketches. In our studio, we like to integrate design, technology, music to create, and human behavior to create a unique experience. So this work was commissioned by the Tower of David, and it's actually around 40 robots playing live music all around this citadel. And the concept was that people can experience this music by walking inside the orchestra. I think that you cannot do in a concert hall. So people could experience this from different heights, from different angles, and from different acoustic playing formats. So actually, each time you walked inside this orchestra, it will be a completely different composition. So,
I want to talk a little bit about the process of creating this installation. Our main inspiration when we were working on this project was in fact the surrounding, the fact that it is located in Jerusalem, a place where three religions and many cultures meet and live together as peacefully as they can. And we wanted to create something that will connect to them, and music seems to be a good way to do that. We chose to work with local instruments such as bells from the churches around, or the Arab drums and rhythms, which you can also see here, and our version of the harp, which according to the tradition was played by King David. We worked on this project for about 9 months, which is a very short time from concept to the opening of the show. All the experts thought it was impossible. And after we made a short process of designing and deciding what we want to display and planning all the mechanisms in detail, we worked with a crew of about 30 people, and they built this thing. The show, as Roy said, spanned over 1,600 square meters. That is a thing that I think cannot be done by live musicians. You can never synchronize musicians over such a big stage. And there were 40 instruments powered by 110 solenoids. These are electromechanical pistons. And all was controlled by a software that was created by David Fire, who is also responsible for the original music that was written. the way that the music was composed was always also in algorithmic way of composing, which is kind of suited the idea of robotic orchestra with an automated music composing. I'd like to show a short piece of a short movie of the Tower of David installation. Yeah, I think so. Okay.
Can we start it?
Yeah.
Did we plug in the audio?
Just a fraction of the real thing.
Okay, so you know what we're going to do? Because we're gonna play it in just a few minutes.
Of course,
so
it all worked before.
No, we saw
test.
playing it a moment ago. So why don't we have a conversation, because we only have a couple of minutes left, and
I just want to say that we have a nice control here, that during intermissions you can come up to us and control this system afterwards.
Since we've been showing robots, I really wanted to talk about some of the things that we've got going over here, and I think that it's really fascinating. So I just want to know, where do you think robots are going? I mean, this is Raffaello. Where do you think that I mean, when normal people think of robots, you had your robots moving around, moving stuff. Everyday uses don't seem too practical, except the Roombas. Now they've got these robots that are going to tell you where your mother is, and that's a really kind of cool thing, or your grandmother or your kids are. That's a situational awareness robots. That's very exciting. But what do you think the real advances, the future of robotics is? Where is it most promising?
Yeah, I wish I knew. One of the things that I can give you some rough ideas, but one of the things that I've learned doing these things over a period of 10 years is that you really don't know. So what's really important is to do innovative stuff, and people will come up with uses. You know, Kiva system was a direct result of working on things that play soccer. I mean, where's the connection between robots playing soccer and hundreds of robots in distribution facilities? Well, it was an entrepreneur named Mick Mounts who saw the RoboCup videos and said, hey, you know, I have a real problem with distribution. He worked at Webvan just before I went belly up. And so, you know, it's unanticipated. Some of the key issues that need to be resolved, and so I'm not going to tell you applications because I don't know, but I can tell you what some of the key issues are. The robustness. Robot systems have to be robust. You know, for example, in our warehouse, they have to run, 24/7. Just to make a video is not good enough. It has to work all the time. And it's very difficult to make autonomous systems work all the time. So key issues are robustness. Other issues are, there's this tension between intelligence and reliability. And it's completely different ends of the spectrum. In a warehouse environment, in a distribution facilities, you want determinism. You don't want these things to be intelligent. You want them to do what they're told. On the other hand, a lot of people are working on artificial intelligence, robots that express emotions, that think like human beings, whatever. Nobody's really sure what the applications are. But if those things are truly intelligent, you're going to have to relinquish control. They're going to do things that you don't know what they're going to do. So I think we have to really understand where we're going with these things.
There's a lot of talk about robotic ethics, this Asimov's law of robots. Are we beyond that? I mean, is that notion completely obsolete? You know, we're seeing robots now going into conflict, carrying weapon systems. The notion that a robot is here to serve man, literally may be true, serving us up in a way. I mean, do we have a lot to fear about robots? Is that a Bubba might say, they would say grandma's tale, or do you think that you know, there really is a kind of do we spend too much time on robotic ethics concepts?
Personally, I do. I think the people that are best suited to explore those issues are science fiction writers. I mean, basically Asimov came up with the 3 laws as a means to explore what would happen if I had those 3 basic laws. What could I write? What interesting stories? And of course, he came up with many, many stories, as did many people that followed him. I think that these people have the creative freedom to come up with conjectures of what things should be, and let's explore all the possibilities. Clearly, you bring up some very good points. It's clear that those 3 laws are not being abided by most successful autonomous systems, the ones that are employed in war, whether it's the Predator or these other ground vehicles that have guns, etc. So, yeah, I think that they're just tools, they're just machines. So what people do with them is the important part.
I have a last video, the dancing robot. Can you show this? This is an unintended use that I don't think anyone was clever enough in science fiction to have imagined, and I found it important enough to share with this august audience because of the serious nature of this quality robot. In the high level of
just enough light to see in the shadows. My only company, and it moves just like me, and it
So it moves beyond the Asimov. Okay, we can wrap that. It moves beyond even the Asimov's principles of basic laws of robotics. So Amir, let me ask you. You know, how do you make robots intelligent enough? Can you make robots intelligent enough? And what are the really interesting challenges that you're trying to accomplish with intelligence? What's your vision of what a robot should do? I mean, snakes is an interesting form. Why are you interested in that kind of thing?
So, is it work? It's working?
Yeah.
So, okay. So, I think the most important challenge, 2 important challenges we have now. One is combining intelligence with the locomotion possibilities of robots in order to conduct simple daily tasks like going from my house to my neighbor's house. For us, it looks like a very simple task, but for a robot, just finding the door, opening the door, that opening the door needs a lot of dexterity. And finding the door, you need to maneuver and to localize the robot needs to localize itself and find its position. And then going down the stairs, going upstairs, navigating outside. That's all are very difficult tasks for a robot. But for us as human beings are very simple, and I think we are getting into the direction that such tasks could be solved in the near future. But you asked about robustness, and I think one of the key issues for the far future would be to have robots that can fix themselves. exactly as we as human beings or biologically creatures can heal from a wounded from a wound and fix ourselves. And that's the far future. If we will have robots that made out of such materials that can be fixed, that would
like
be
the chair.
Yeah,
like the chair. Yeah.
Roy, I wanted. Was what you're doing robotic, or is it something else?
Well, this time we used it as a tool to create this experience, and we worked with a composer, and for him it was a very empowering experience because he got to sit in this huge citadel all alone when he was practicing, and he could control these faraway instruments. And for him, I guess it was very like, wow, it was a great high. We couldn't take him out of there when the crowds went in. And so for him, it was very empowering. And for the audience, it was very magical because things were just happening where they didn't happen before.
I thought the most fun part was in the fact that anybody could play it too, that you had options that you would let people, you know.
Yeah, this option we developed especially for DLD.
Yeah.
So
we're going to let people do that. Okay.
Yeah, later.
Okay. No, because I think that's just absolutely tons of fun. I'd like to kind of close this discussion if I can, because I want to stay on time. But I want to talk about the thing that you and I were discussing, which is, you know, if people thought we were going to do robots, they had the Asimo thing here, and I had the Aibo and the dog and stuff, and we showed things that didn't look particularly practical in a certain way. Yet, is there something practical about the snake? Is there something practical about the chair? Is there something practical about the kinds of things that you're doing? And what are the risks of focusing on the practical as the first driver? Is always focusing on the practical the right thing?
I think that, you know, I'm at a university. I think a university needs a portfolio. It needs a portfolio of people that work on targeted research, but it also needs a portfolio of people that work on fundamental issues. And there's a risk associated with doing untargeted research, which is what we try to do. But the rewards are also much greater because things come out of it that you can't anticipate. So it's really, you need a balance. You can't, you know, the danger of everybody focusing on targeted research is that we're missing out on a lot of things that could happen if we just gave a little bit more freedom to the people developing it. From an educational perspective, the students love working on untargeted stuff. You know, they don't want to work on things that are going to be used to drop bombs on people. They'd rather work on cool things. You know, we work on flying vehicles where we're not doing military research. We're just doing stuff that's a lot of fun. So there's the educational part. I think it really empowers the students to learn in a very supportive environment. So I would say that those are the key issues.
As a person who's been dealing with getting a multiple series of aircrafts to fly within a small area, you know, my mother looking at it says, yeah, that's great, but why don't you get an education? You're flying around, you know. How do you answer my mother? I'd like to know.
I guess it's very simple. You don't know what you don't know.
Yeah, say again?
You don't know what you don't know. To quote Ransfield, which I hate to do, but you don't know what you don't know.
And what have you found having I mean, what kinds of things have been breakthroughs in your own mind and your own intellectual discovery with
a few years ago, if you took, you know, if you showed someone, you told someone that you could have these quadrotors hover in a space and do flips and do aerobatics, people would say that's impossible, as usual, of course.
Right.
And now, you know, we have these things flying, and in fact, now we want to see if we can interact with people more. So actually, since this is, you know, a Web 2.0 conference, we're always open to suggestions as to how to make this autonomous system more interactive with people. So one idea is, for example, we could fly these vehicles to music, but then how do you do the choreography? You know, it's a very difficult thing to do autonomously. So maybe you can have people submit different choreographies and kind of compete and do all of that stuff.
And Amir, when your mom looks at the snakes and says, enough with the snakes already. Can't you do something useful? Can't you have groceries delivered? What do you say to mom?
So,
or like that?
yeah, so if you get paid for playing with toys, so what's better than that?
Right. I understand, but yeah, okay. So you're getting paid for dealing with toys, but what's it good for? How are you helping us?
Well, this snake robot can be used for search and rescue, to crawl underneath a collapsed building and look for survivors. And this is a real issue and real application for these robots. And they actually, in the US, they actually use it.
For that purpose?
Yeah, for that purpose. I worked at Carnegie Mellon on snake robots, and they use snake robots there as the first mission to go into a collapsed building.
And even if there wasn't an ideal use in the immediate sense, how would you answer a comment like that?
Right, and it's really the three things, right? One, it's a great educational tool. Segej can go anywhere and work. You know, the things that he's learned working on RoboCup, the DARPA Grand Challenge, now these autonomous vehicles, I mean, he has this knowledge which many people that have been working for 50 years don't have. And he's gotten that by working on these systems. So there's the educational perspective. You have unanticipated consequences. Kiva is a good example of that. You know, when we did RoboCup, Robot Soccer, we didn't have it in mind that we were going to build distribution facilities, because I didn't even know what a distribution facility was. And the third is, I think it leads to a better relationship with society. I think showing that technology is not just about making something cheaper, faster, to feed consumerism. It can just be for enlightenment.
And we're gonna conclude now. I'm asked to conclude, but we're gonna conclude in the way I like to conclude, which is with a fanfare for the common man here, a drum sequence that you're going to do, and that will conclude it. And people can come up and take a look at this and operate it themselves. Okay.
Okay, can we turn the mic on again? Okay, so everybody who wants to play can come on stage and play with the drums. We now have our big break, our lunch break. There's the big lunch area up there. There's a special media lunch at the Strenes shop in the Fünfhöfe. If you want to join, please just join us. Go to Strenes in Fünfhöfe, it's another separate lunch.